Okay, we're going to look at some right-angled trigonometry. So right-angled trigonometry is pretty much always using SOHCAHTOA. So the key thing to remember here is SO, CA and TOA. And that is the acronym that helps you to remember whether we should be using sine, cos or tan. So all this means is sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. Okay, so each of these could be written like this. Okay, so for the first question here, so this one, we have an angle of 60. Now when we label it, what we mean by the opposite, hypotenuse and adjacent is how we label the triangle. So if this is my angle in the corner here at 30, and you'll always either have that given or be told to find one, then the opposite is the side that's opposite that angle that's not connected to it. So both of these are connected to the angle, so it's not those, it must be the one that's opposite and completely separate. So this would then be called the opposite angle or the opposite side. The hypotenuse is always the longest one, which is the slanted one opposite the right angle, and then the adjacent is this one here. So we have the opposite, hypotenuse and adjacent. Now we're trying to find the hypotenuse and we've been given the opposite. So that means that in our SOHCAHTOA, they're the two we want to be using. We have nothing about the adjacent, we don't need that at all. So it's the one you're trying to find and the one that you've been given. So the H and the O is in this one, which is SOC. Therefore, we're going to be using sine. So sine of the angle, and the angle was 30, is equal to the opposite, which we're told is 6, over the hypotenuse, which we're unsure of. And once you've got that, you can type that straight into your NSolve. So sine of 30 equals 6 over question mark, comma, question mark. Okay, so NSolve, and that will then give you your answer, which is 12. So we now know that the hypotenuse is 12 centimeters long. So that's just from typing it into NSolve. So for the next one, again, you've been given one of the angles. So the first thing to do is to label it. So the opposite is over here, the hypotenuse is the longer side, and the adjacent is this side down here. So we're trying to use, or trying to find the adjacent, and we've been given the opposite. So we're going to be using the A and the O. So that's using tan, that uses the A and the O, and therefore tan of the angle, and the angle here is 36. So tan 36 is equal to O divided by A. And again, I can use my GDC and my NSolve to find what that angle would be. Okay, or to find what that length would be. So I find that it's 13.76. So to three significant figures, it's 13.8 centimeters. Okay, so 13.8 centimeters there. And that is the adjacent. The next one, so I'm looking at this triangle here. Again, I need to label it first. So I have my opposite, my hypotenuse, and my adjacent. And this time I'm trying to find the opposite, and I'm given the hypotenuse. So I'm using the O and the H. So again, this one's sine. So sine of the angle equals the opposite over the hypotenuse. And again, I can just type that straight into NSolve to find what the missing angle would be. Missing length, sorry. And it tells me that it's 3. So the opposite there is 3 centimeters. The next one, again, finding the opposite, and I'm given the adjacent. So opposite and adjacent mean that I'm using the tan function. So tan of the angle, which is 72, is equal to the opposite over the adjacent. And again, just using my end solve button. And I'll be typing that in to see what is the length of the opposite, which is 6. That doesn't sound right. Tan 72 18.46. So to 3 decimal places, to 3 significant figures, that is 18.5 centimeters. For this next one, I'm going to be using Pythagoras in order to find the length, because I don't have any of the angles given. Okay, none of those are given, so I can't use SOHCAHTOA. So instead, if you're just using the length of sides and you have a right angle triangle, then you can use Pythagoras. It only works with a right angle triangle. So using this one here, I know that 8 squared plus something squared equals 17 squared. So 8 squared plus something squared equals 17 squared. And then again, I can just use my GDC and my end solve to work out what that would be. And it gives me the square root of 225, which is therefore 15. So this is 15. Now that I know that one, I can now use this right angle triangle, where I know that this squared plus this squared equals this squared. So again, I can type that into my end solve and find the missing piece of information. So this time 15 squared plus something squared equals 25 squared. So just typing that into your GDC. And you'll find that that gives you 20. And now we're on to that last triangle where we know that this squared plus this squared equals this squared. So again, I can type that in. So 20 squared plus 48 squared gives me my answer squared. And that gives me an answer of 52. So x there is 52. And the next one, or the last one that we're looking at, is a question using some algebra. So again, it's Pythagoras because I don't have angles, I only have sides. And I know that this squared plus this squared equals this squared. So that forms an equation. So I have 4 times x plus 2 all squared plus, and then I have x plus 3 squared, and that equals 25 squared. Now that is using a quadratic. If I multiply that out, I get quadratics. So I'm going to need to multiply it out by hand. So both this part and this part. Rearrange it and make it equal to 0. And then I can use the menu algebra polynomial roots. And that will allow me to find the solutions to that quadratic and to solve it. Okay, so that's part of the quadratic solving. So a little bit about terminology. Sometimes when you're asked to do these questions in context, you might be asked to find an angle of elevation or an angle of depression. So an angle of elevation is if you are stood at the bottom of something and you're elevated, so you're looking up at something. It's the angle that you're looking up at. And an angle of depression, depress is when you push down, and therefore it's the angle as I look down at something. So angle of elevation is looking up and angle of depression is looking down.